So in this video I'm going to tell you about how to use a breadboard. So what a breadboard is an area where you can build a circuit, and I'll show you how it functions later, but the nice thing about breadboards is you can take a bit of wire like this one, which has some exposed metal. You plug that into one of the holes on the breadboard, and once you've done that, it's quite a robust connection. It doesn't fall out easily, and that's nice because then you can build a circuit on here, and when you're done working on it for the day, you can just then put it in your toolkit, and it'll be fine the next day when you come to use it again. You don't have to take things apart because the breadboard allows you to build fairly robust circuits. Now, to get your wire prepared to stick it in the breadboard, you want about 1 centimeter of wire exposed at the end. So you've been given wire cutters in your toolbox, and you just stick about 1 centimeter of the wire through there, waggle it back and forth to break the insulation, so let the jaws cut it, and then that bit of insulation should come off fairly well, and you've got the metal exposed here. Now, if your wire cutters are doing a poor job of doing this, that is, maybe they're not cutting the insulation, or maybe they're cutting too deep and actually nicking the wire so that it falls off. If that's the case, grab a screwdriver and you can adjust the position of this screw, because that's what acts as a stop on how far the jaws go on the wire cutter. So adjust it as you need to, but it should be fairly close to all ready to go right now. Now, to understand how to build a circuit with a breadboard, you need to understand how things are electrically connected underneath the plastic. So I've got another breadboard here, and this one has the back of it stripped off, so you can actually see the pieces of metal that run underneath the surface of the plastic here. So what you'll notice is in the body of the breadboard, there's all these little strips like so. So what that means is that the strips of 5 holes up here are connected electrically. They've actually got a piece of conducting wire underneath the plastic that connects them all electrically. So every strip of 5 is all connected together, shorted together via a piece of metal. So that means when you want to plug in, say, a resistor to your board, the proper way to plug it in is like so, where each leg of the resistor goes into a different set of 5 holes. So then you can, for example, run some electricity into one end of the resistor and run it back out to ground on the other end. And what happens is, this is the current coming in, and this is at 5 volts, and it comes in here, connects to the resistor via the metal underneath the plastic, goes through the resistor, again connects via a different strip of 5 underneath the plastic to this wire, and then it goes out to ground. So this is the correct way to hook up a resistor so that each of these legs is into a different strip of 5 holes. If, for example, you plugged it in like this, such that both legs are in the same strip of 5, that means that you've shorted out your resistor. So the electricity has a shortcut to go past this resistor, and that's what it'll do, is it won't go through the high resistance pathway. It'll go through the low resistance one underneath the plastic. So don't hook it in with both legs going to the same set of 5 holes. Hook it in like so, so that they go to a separate strip of 5 holes. Now, another thing to notice on here is in the body of the breadboard, we've got all those strips of 5 holes connected together. Along the edges, it's different, as there's these 2 long rails that go along the edges of the board. So then that means that here, on this main body of the board, is along the edges, there's 2 long sets of holes that are all electrically connected to each other on both sides. We use that to bring 5 volts and ground to the circuit. So what you've got over here is a hookup for your power. So you've got a DC adapter, and you would plug this into the wall, and then you plug this end into this red board here, and when you turn this on, a LED will come on to show you that you've got power to the board. And what that does is it hooks up 5 volts to the red rail and ground 0 volts to the blue rail on both sides here. And so if you needed to jump 5 volts, for example, to one point in your circuit, you could just hook a wire directly from the red rail over to whatever point you need. Same thing with ground, is you could just put a jumped wire in to whatever point in your circuit you want. That's what's happening over here, by the way, is you've got a chip, and you're going to be programming this chip but the chip needs power in order to function. So if this hasn't been done already on your board, you'll need to do it with some short wires yourself, but you want to hook up 5 volts and ground on both sides of your chip to the correct pins on the chip. So there's a little sticker on here. It's also a good idea to look at the chip diagram in the front cover of your lab manual and make sure that you know exactly what pins to hook up. But you'll need to put 5 volts and ground to both sides of your chip in order to program it. Now, depending on which programmer you're using, your board is either going to look like this or it's going to look like this, also with a red regulator bar over here. But notice these ends here. So with the older Picket 2 programmers, this is how you program your chip, and you would just plug in your programmer to that set of pins on the end of your board. And this is glued on, looks a little kludgy. We have newer Picket 3s that are slowly being phased in. Those ones have a 3D printed bracket. Your Picket 3 looks exactly like this, except it's bright red, and again, you would just plug it in to these pins on the end here. The Picket 2s and the Picket 3s are not interchangeable. Just be aware of that. If your buddy has a Picket 3 and you've got a Picket 2, you can't swap. They're wired differently. But as I said, the Picket 2s, you'll see this glued on connector. With the Picket 3s, they'll have a bracket also with a connector. And it's just a case of you plug in with your Picket right side up in order to program your chip. So let me tell you a few things about the Pickets themselves. So care and feeding of your Picket device. These things do break sometimes, and the place where they're most likely to break is the little USB connector right here. Just if this gets a little bit of torque and things break down inside, and the technician has to open it up and actually solder things back into place. To prevent that from happening, when you're storing your Picket, unplug it like this and just throw the actual programmer and the USB cord into your toolkit separately. And that way, this little connection's not going to be getting that torque just due to things flexing. So I'll now give you a few extra tips, which are just handy things to know. So first of all, and this is probably pretty self-explanatory, if you smell smoke, turn off the power right away. You could be in the process of burning out your chip. Obviously, we should never have anything going on the circuit that causes things to heat up to the point where plastic is burning or you hurt yourself on the regulator or something. So if you smell something funny, turn it off right away. Figure out what's going on with your circuit. Next, it's a good idea to avoid these sort of big spaghetti wires. It's probably not a big deal for really simple circuits, but especially when things start getting more complicated, you want to get rid of these big loops of wire for a couple different reasons. First of all, they're the ones most likely to pop out. Second of all, it makes troubleshooting really difficult when you've got these big loops of wire. It's pretty hard to trace where exactly everything's going if you've got spaghetti happening above your circuit. Instead, go for shorter sections of wire, and as much as possible try and make your circuit look two-dimensional. It just makes it easier to trace exactly what is going on. Third reason why is those big loops of wire can actually pick up EMFs, even from like the overhead fluorescent lights, and that can cause unpredictable behavior in your chip. So in general, especially for more complicated circuits, make sure everything's nice and flat as much as possible against your board. Makes it easier to trace, and also makes for a more robust circuit. Another thing to be aware of with these chips, this is usually not a problem, but it is possible to have just, say, one bad port or a couple of pins or just one pin that is not functioning. Usually you never have a problem with that because we put new chips in pretty much every year, but just be aware that if you've been troubleshooting your circuit and you're sure everything's built right, you can't figure out what's going on, your lab instructor can't figure out why it's not working either, it could just be that you have one bad port on the chip, and if you move to a different one, everything would work fine. So just be aware that's a possibility, although as I said, it's pretty rare that that's actually the problem. It's usually something in the wiring is wrong if things are not working properly.